two objects, M1 is 5 kg and M2 is 3 kg, are connected by a light string passing over a light frictionless pulley as in figure P5.71. So this is the initial state here. And then the 5 kg object is released from rest at a point h is equal to 4 meter above the table. So this h here is 4 meter. And then A, determine the speed of each object when the two pass each other. When the two pass each other, it is, I expect, in the middle like this. So this one here is 2 meters, right? And then this one here is also 2 meters because it is halfway, right? And this is moving down, this is moving up because M1 is heavier than M2. So I will expect it like this. And then B, determine the speed of each object at the moment 5 kg object hits the table. So this has been on the table like this just before hitting the table. And this h here is 4 meter. So this is situation for A. And then this is our situation for B, right? And let's analyze one by one. So determine the speed of each object when the two pass each other. Okay, so let's use the conservation of mechanical energy. So the mechanical energy in this initial state, let's name this ME0, is equal to the mechanical energy in the situation A, right? And let's analyze that on details. Here in the initial state, we don't have any potential energy on M2, and we also don't have any kinetic energy in M2, but we have some potential energy in M1, right? So I will have potential energy in the M1, right? And then let's move on to this picture A here. And here we have M1 here moving down, right? It has some speed, and M2 also moving up like that. So we have potential energy in both M1 and M2, and also we have kinetic energy in both M1 and M2. So I will have potential energy of M1, and then plus potential energy of M2, and then plus kinetic energy of M1, and then we also have kinetic energy of M2, right? And let's plug in the formula here. So I will have M1 here, and then multiplied by G. The height here is 4 meter, or I will just write it as H. And then this one here, the potential energy of M1. So I will have M1 G, and then we have H over 2. Good. And then plus potential energy of M2. So I will have M2 G, and then multiplied by H over 2. And then kinetic energy of M1. So I will have 1/2 M1, and then because they are moving together, the speed will be the same, right? So I will have just to use V. So I will have V squared, and then plus kinetic energy of M2. So I'll have 1/2 M2 multiplied by V squared. Good. Now all that we need to do is plug in the numerical values. So here I will have M1 is 5, and then 9.8. and then multiplied by H. So I will have 4. Good. And then we will have this one, 5, 9.8. And then for H over 2 is 4 divided by 2. That will be 2. And then plus, now for GM2, M2 is 3 kilograms. So I will have 3 multiplied by 9.8 and then multiplied by 2. And then plus 1/2 M1 is 5, then multiplied by V squared, and then plus 1/2 multiplied by m2. m2 is 3, and then multiplied by v squared. Okay, now on the left hand side, I will have 5 multiplied by 9.8 multiplied by 4. And I will have 196. 196. And then for this one here, I will have this one. This is multiplied by 2, and then plus 3 multiplied by 9.8, and then multiplied by 2, right? Good. And I will have 156.8, 156.8, and then we will have plus this one here. I will have 1/2 plus multiplied by 5, 1/2 multiplied by 5, and then plus 1/2 multiplied by 3 for v squared. And I will have 4 v squared. Good. And I think I can just rearrange this for v, right? So I'll have v, that will be the square root of 196 minus 156.8 divided by 4. And I think we will have the value here. Okay, so let's plug that in. The square root of 196 minus 156.8 divided by 4. And we will have 3.13. So I have 3.13 meter over second. So that is the answer for question A. Okay, now let's move on for question B. Okay, now let's do the same thing for question B. And in this case, I will compare the mechanical energy in the initial state with all the mechanical energy in question B, right? And here M2 does not have any potential or kinetic energy, and M1 only have potential energy. So I will have this one here is potential energy of M1. And then what else? Here we have M1 almost hit the table, so it has kinetic energy. So I will have kinetic energy of M1. But then it does not have any potential energy, right? Because we use the table as our reference. And then we will have plus. Here M2 has potential energy, right? So I will have potential energy of M2. And then plus, we also have kinetic energy of M2, right? Because it is still moving up, right? And this is moving down, almost hits the table just before it. So I will have kinetic energy of M2. Good. And here we can just plug in the formula. This one is M1 multiplied by G multiplied by H. And then this one here, the kinetic energy of M1. So I have 1/2 mass of 1, and then V squared. And then plus potential energy of M2, so I will have not 1/2, mass number 2 multiplied by G multiplied by H, and then kinetic energy of M2, so I'll have 1/2 M2 and V squared. Why the speed is the same? Because they are moving as one system, right? The speed is the same, just the direction is different. Okay, now let's plug in the formula. So I will have 5, and then G is 9.8, H is 4. Good. Then we'll have 1/2 multiplied by M1, that will be 5, and then V squared, and then plus, we will have this one here, 3 multiplied by 9.8, then multiplied by H, that will be 4. And that is added by 1/2, and then 3, and then V squared. Okay, for 1/2 times 5 and then 1/2 times 3, that will be 4v squared, right? So I have 4v squared. And then on the left hand side here, I will have 9 multiplied by, 5 multiplied by 9.8 multiplied by 4, and then minus 3 times 9.8 and then multiplied by 4. And we will have 78.4. So I have 78.4. And then we can just plug in rearrange this, right? I will have square root of 78.4 divided by 4. Okay, and that will be square root of 78.4 divided by 4. And I will have 4.43. 4.43, and the unit here will be meter over second. So that is the speed of M1 just before hitting the table, 4.43 meter over second. And that is the answer for question B. Okay, now let's answer question C. Okay, now for question C, we have pure kinematics here, right? Because this one has initial velocity of that one. V0 is 4.43. And then it is still traveling up, right? And it will stop somewhere here, right? So I will have this one here. So I will have Vt here is equal to 0 meter over second. So I'll have Vt is equal to 0 meter over second. And because it stopped here, it has some deceleration, right? And what is the deceleration? It is equal to g. So I have minus g here as our acceleration, or our acceleration is actually minus 9.8 meter over squared second. And we are looking for the displacement, so I will have this y here. And we can just use kinematic formula. Vt squared is equal to V0 squared and then plus 2 multiplied by A multiplied by Y. Okay, so Vt squared, that will be 0 squared, and then we'll have 4.43 squared, and then plus 2 multiplied by minus 2 minus A, so I'll have minus G, that will be minus 9.8. Then multiplied by Y, Y is the one that we are looking for. So we'll have 2 multiplied by 9.8y is equal to 4.43 squared, and so we'll have y is equal to 4.43 squared divided by 2 multiplied by 9.8, right? And that will be, what is that? 4.43 squared divided by 2 multiplied by 9.8, and that will be 1 meter. And I think that is all the answer. So the answer for question C is 1 meter. So this is the answer for question A, this is the answer for question B, and this is the answer for question C. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.